Well, welcome, grade 11s. This is your mathematics teacher, and we're just doing a revision for your term 1 test. Okay, now these are all the topics we've done so far, starting all the way from grade 8 to grade 9 to grade 10, yes, including grade 10 stuff, and grade 11. So let's just get right into it. Okay, so the first question is 1.1, and we have solved for x. Given x, 6x plus 1 is equals to 0, right? So I've got 2, okay, 2 x's here. So the first one, I'm just going to simply say x is equals to 0, or the other one is this one in the bracket, which is 6x plus 1 is equals to 0. And then I solve for x. I take the 1 to the other side. I'm left with 6x is equals to minus 1. Divide both sides by 6. And I have x is equals to minus 1 over 6. Well, that's it. Let's go to the next question. It says 1.2. Now I've got 4x squared minus 4x minus 3 is equals to 0. So for this kind of questions, I've got a number here, so I'm going to do the operation where I multiply this with that. 4 times 3. 4 times 3 is 12, and then I'm going to look for factors of 12 that will give me 4. So the first one is 1 and 12, of course. 2 and 6, 3 and 4. Okay, let's just stop right there. Now, which one of these can give me a 4? I can see it's a 2 and a 6 right there, but in what order? Which one is negative? The biggest one is negative. So it's negative 6 and plus 2. Negative 6 and plus 2 are going to give me a negative 4. But also this number is negative. So when I multiply 2 and 6, plus 2 and negative 6, they will give me a negative and a sign over there. So that's cool. So I'm just going to put them. I'm going to say 4x squared, and then rewrite this minus 4 as plus 2x minus 6x, and then I write this minus 3 over there. Okay, it's equals to 0. Okay, so now I'm factorizing. I'm going to start by factorizing these first two over here, and then I'm going to factorize finally these ones over here. Okay, let's start with the first two. Common factor between 4 and 2, highest is 2, and then I have an x as well. Okay, to get this expression 2, I need to multiply it with 2, and then x squared, I need an x there. Plus, to get a 2x, I need to multiply that with just 1. Cool. Now, factorizing this one, take out the common factor of minus 3, and then inside the bracket, okay, to get 6x, I need to multiply minus 3 with 2x. And then to get minus 3, now watch out for the signs, I need to multiply minus 3 with a plus 1. Just like that, equals to 0. Now I need to factorize by taking out the common factor, which is 2x plus 1. And then to get this expression, multiply that with just 2x. And then to get that expression, multiply that with just minus 3. That's equals to 0. Is that cool? Now, what I need to do now is solve for x, because that was the question. So, I'm going to say for the first one, 2x plus 1 is equals to 0, or this side it's going to be 2x minus 3 is equals to 0. Okay, just those two brackets expanded, so I'm gonna put that and then I'm going to take this one to the other side such that it becomes 2x is equals to minus 1. This side I take the 3 to the other side such that 2x is equals to positive 3, and then finally divide both sides by 2, and I'll be left with x is equals to minus 1 over 2. This side, divide both sides by 2, and left with x is equals to 3 over 2. Right there, we are done with that question. Let us move on to the next question, which is 1.3. All right. This time we have an inequality of 3x squared minus 2x 0. Oh, by the way, in this question here, if you did not want to factorize, you could have just put it in the quadratic equation. I think it will be easier that way. Okay, but we'll do it with this one. Okay, so with this one, what I will do is that I need to factorize this first. And in factorizing this to solve for x, to find my critical values, I can take x out, and then I'm left with x minus 2, isn't it? Is it? No, I am missing a 3 right here. It's 3x. Okay. So for my critical values then, my critical, I'll call them CV. My critical values, I have x is equals to 0 and x is equals to, if I take the 2 to the other side, it becomes positive, and I divide both sides by 3, 2 over 3. Okay, now I have my critical values, right? So I plot them. Okay, I draw that line there. Which one is bigger between 0 and 2 over 3? Of course, 2 over 3 is bigger, so it comes over here. And then 0, this side on the left. Okay, so, and then I just draw a rough sketch like that. Now, I'm looking for values where this expression is less than 0. So if I put my hand on the line and I look underneath, because I have 3 options, either it's going to be from negative infinity to 0, or 0 to 2 over 3, or 2 over 3 to infinity. I have 3 options. Which option I choose is based on this inequality sign. Now I'm going to put x and then that inequality sign. Now which one is the answer where it's below the graph? Below the graph, I see it from 0 on the left to 2 over 3 on the right. That's my final answer. That's the only option that I choose. Okay, now moving on swiftly to the last question of question 1, which is now 1.1.4. Now I have the square root of x minus 1 plus 24 over square root of x minus 1 is equals to 10. Look at that. What I'm going to do here, I'm going to use what's called the K method, where I will say let K equals, I'll make it equals to this whole square root thing, x minus 1, and then I'll be left with K here plus 24 over K, right, is equals to 10. Now I need to get rid of this fraction by multiplying with K everywhere, times K, times K, times K. Okay, and then I'll have k times k, which is k squared, and then these k's cancel each other, and then I'm left with just 24, and then this side 10 times k, it's just 10k. Right, going to rearrange, bring it on one side. Okay, bring everything to one side, and then I'll have k squared minus 10k plus 24 is equals to 0. Now I need to factorize this. I'll open two brackets. Okay, it's equals to 0. Factors of 24, let's go. So I got 24. 1 and 24, of course. Will it give me 10? No. 2. 24 divided by 2 is 12. This one looks promising. So, well, it's not so promising, because if I make 12 negative and 2 positive, that negative and positive will give me minus 10. But when it comes to multiplying a negative and a positive, they will give me a negative 24, but I have a positive 24, so that's not going to work. Let's try a 3. Okay, I do not know what 24 divided by 3 is. It's 8. 3 and 8. Let's try a 4. 24 divided by 4. That's 6. Okay, let's try this one now. Okay, so if I have 4 times 6, it will give me a positive 24, but okay, they will give me a positive 10 if I add them. But if both of them are negative, like this, and then a negative and a negative multiplied, they will give me a positive 24, and a negative 4 plus a negative 6, they will give me a minus 10, which works out. Now I'm going to put a k there and a k there, and then I'll put minus 4, minus 6. So that means k is equals to 4, or k is equals to 6. Let's go back there. Remember we said k is equals to the square root of that. Let's put that. So this side I will have the square root of x minus 1 is equals to 4, or this side the square root of x minus 1 is equals to 6. All right, now with this one, in solving x, I square both sides, right, to get rid of the square root, and then I'll be left with x minus 1 is equals to 4 squared is 16. Or this side, do the same thing, square both sides, and then I'm left with x minus 1 is equals to 6 squared is 36. Then finally, if I take that x on one side, I take that minus 1 to the other side, becomes positive, then it's 1 plus 16, which is 17, or x is equals to 36 plus 1, which is 37. These final answers. Okay, so we use the k method to solve here. I hope you do remember it from grade 10, but let's go over now to question 1.2. Okay, let's do question 1.2 now. It says solve simultaneously. Cool. So I've got x plus 2y is equals to 3, and then I've got x squared, interesting, minus 8x plus 8 is equals to 8y minus 2xy. Okay, so I'm just gonna name them. This is my equation 1, that's equation 2. Which one is the easiest to create equation 3 with? It's equation 1. and which one doesn't have a number next to it? It's x. So I'm going to make x the subject of the formula. It becomes 3. Take this 2y to the other side, minus 2y. So now this becomes my equation number 3. From there, now I use equation 1 to create equation 3, which means I cannot substitute into equation 1, but I substitute equation 3 into equation 1. No, equation 2, because I've already used 1, so I can't use it again. Okay, so that means where I have an x, I will substitute this. The first one, I have an x there, it's squared, so I'll open a bracket and I'll put what x is equals to, and it's equals to 3 minus 2y, and that is squared, minus 8. I have an x again, so I open a bracket and I put what x is equals to, and it's equals to 3 minus 2y. Close that, and I have a plus, and I have a 8, and I have a equals, and I have a 8, and I have a y, and I have a minus, and I have a 2. I have a x again, so I'm going to substitute what x is equals to. It's equals to 3 minus 2y, and then finally I have a y. Now it's just a matter of expanding. Every time you see a square, please open two brackets. So I'll have a 3 minus 2y and another 3 minus 2y, and then I'll multiply this one out. Cool. So this one, it's 8 times 3. What is 8 times 3? It's 8, 16, 24. So it's going to be minus 24, and then a minus 8 times a minus 2 is a positive 16y. There we go. Plus 8. This side I have 8y, and then minus 2 times 3 is minus 6. There's also a y there, so it's going to be multiply the y as well together like that. So it's minus 6y, and then the next one will be that minus 2 and a minus 2 will multiplied will give me a plus 4, and then there's also a y there, so it's a y times y, which is y squared. Okay, let's move on. Let's do a bit of gymnastics. Let's continue. 3 times 3 is 9. 3 times 2y. 3 times 2 is minus 6y, and then this one 3, it's minus 6y again, and then this one minus 2 times minus 2 is plus 4, and then y squared. And then these ones I'll rewrite it exactly as it is. Minus 24 plus 8. Let me combine that. Let's get a calculator. So it's minus 24 plus 8. Please try this on a calculator. Don't think of yourself as a hero. Okay, so it's just minus 16 plus 16y. Okay, easy numbers, put them in a calculator. 8y minus 6y, that's 2y, plus 4y squared. So what I'm going to do now is put everything on one side, or maybe put variables on one side and numbers on the other. Let's see if that works out. Let's start with the variables. So I have a minus 6 here, so I'm going to go minus 6. I have minus 6 again, minus 6. In terms of y's, do I have another y? There we go. I have plus 16. What about on the other side? I have 2y, but it's on the other side, so which means if I bring it this side, it becomes minus 2. Minus 2, and that's equals to 2. So I have 2y. Now, if I look at the y squared, I have this one and that one. So if I bring this one to the other side, they cancel each other. That's 0. Okay, now let me look at the numbers. The numbers as they are, I have a 9 there, and then I have minus 16. Minus 16. Is there any other number? No. So what's that equals to? It's equals to minus 7. And it's on this side. But I want it to be on the other side. So when I take it to the other side, it becomes positive 7. So there we go. Y is equals to 7 over 2. Divided both sides by 2 to get 7 over 2. So you try this. You try this. You try it. Make sure we get the same answer. Okay. So equation number 3 is to solve for x. We use equation number 3, which is x is equals to, forgot it, 3 minus 2y. So 3 minus 2y. Okay, so that means where I have the y, I'll substitute this number, minus 2, and that number is 7 over 2. Okay, now look at this. These 2's cancel each other, and then I'm left with 3 minus 7. What's 3 minus 7? It's minus 4. Therefore, in my conclusion, x is equals to 7 over 2 and y is equals to minus 4. That's it. Let's move on to the next question. Okay, let's look at question 1.3.1. It says, for which values of m will the following equations have non-real roots? Now, when we're talking of roots, we're really speaking about the discriminant. And what is the discriminant? It is b squared minus 4ac. Now, what is the condition of non-real roots? We know that the discriminant has to be less than 0, which means it has to be negative, less than 0. Why negative? Because anything, okay, that is negative under a square root is non-real. No matter what it is, it's always non-real. So that's the condition. Okay, so we have to have our equation in the standard form first, which is ax squared plus bx plus c. Okay, now let's look at the equations we given. In the first one, we are given x squared minus 6x is equals to m. So I have to take m to the other side so that it's in the standard form, and I'll have x squared minus 6x minus m is equals to 0. Now I need to identify a is there, b, that's b, and c is minus m. Cool. Now let's put this under the discriminant, which is b squared, and b is minus 6 squared minus 4. The value of a is 1, and then c is minus m. All of this has to be less than 0. That's the condition. And then I'll have 36 minus, I have a minus here and another minus there. Combine and multiply, they make a plus 4m. All this is less than 0. If I take 4m is less than, if I take the 36 to the other side, it becomes negative 36. Divide both sides by 4, divide by 4, divide by 4, I get that. Therefore, m is less than negative 36 divided by 4 is minus 9. Okay, so that's my final answer. All right, let's look at the next one. doesn't look so bad. For the next one, same thing, the discriminant still has to be less than 0 for 1.3.2. So let's put it in the standard form. It's x squared plus mx plus 4 is equals to 3x. So I'm just going to bring the 3x to the other side, such that I'll have mx minus 3x. See, I just brought it to the other side, plus 4 is equals to 0. Now what I want to do is factorize by taking the common factor out, which is x. Okay, so it's plus x, and then here I will have m minus 3 plus 4 is equals to 0. Let me identify my a. There's my a, it's just 1. My b is this whole thing, m minus 3, and then that's my c. Come back to the discriminant, which is b squared minus 4ac. This has to be less than 0. So b squared is m minus 3 squared minus 4. A is 1, and then c is 4. Okay, all of this has to be less than 0. Don't try to be a hero. You see a square, just open 2 brackets. Okay, I prefer that because it's very easy to make a mistake. We don't. 4 times 4 is 16. All of this is still less than 0. Now let's multiply this out. M times m is m squared. M times minus 3 is minus 3m. Minus 3 times m is minus 3m. Minus 3 times minus 3 is plus 9 minus 16. This is less than 0. Okay. What now? What do we do now? Well, let's combine it. It's m squared minus 3 is minus 6m. 9 minus 16 is minus 7. I think so. Okay. Now let's open 2 brackets. To factorize, you need to get the critical values, because I'm solving critical values. Now it's similar to this 1.1.3 question with an inequality. Okay, we need critical values. I'll put an m on both sides, and then to get minus 7, I multiply 7 and 1, and then watch this. To get minus 6, I add minus 7 plus 1. All of this must still be less than 0. So what I'm going to do is I'm going to say critical values are m is equals to 7 and m is equals to minus 1. So what does that mean? That means on my number line, I'm going to identify minus 1 and 7. And then I'm going to draw this graph right here. And then now, depending on the condition, that's how I'm going to define my answer. Because my answer, I have 3 options. Either it's going to be from negative infinity to negative 1, or from negative 1 to 7, or from 7 to positive infinity. Only one of them or 2 of them can be the real answer. That depends on this inequality sign. And it says less than. That less than means below the graph. Now below the graph, I can see from negative 1 to 7. So that's my final answer. So I'm going to have m, that inequality sign, from negative 1 to 7. Yeah. That's my final answer. Okay. Let's look at the next question then. And the next question is 1.4. 1.4 says consider the expression Rx is equals to square root of that. What is the minimum value? So here we want the minimum value of Rx. So that means we want the minimum value of this whole expression, the whole expression of x plus 2. We want to know what is its minimum value. Okay, so here's the game plan here. Here's the game plan. To get the minimum value, first we can see that this is we'll multiply this out, okay, like this. There's a square there, open two brackets, x plus 2, x plus 2, so that we just put it in a standard form that we are all familiar with. And then it's going to be x times x, which is going to give me x squared, and then x plus 2x, and then 2 times x plus 2x, and then 2 times 2. What am I doing? 2 times 2 is plus 4, and then I have plus 9. All right, so now let's combine it. It becomes x squared to 2 plus 2 is plus 4x, and then 4 plus 9 is plus 13. Okay, now it looks a little better. Now it's in a standard form. Now we want a minimum value of all of this, which means we need to solve for the value of x such that this will give us the whole when we substitute x back, it will give us the least amount of, how can I put it, the least value it can. So this is a quadratic graph. It looks like that, right? And we know it's at its minimum, at its turning point right there. So to get the x value of the turning point, we know it's minus b over 2a. Okay, so we need to identify a, b, and c again. That's a, that's b, and that's c. Okay, so when it comes to the values, so I'm going to have minus b is 4 over 2 times a is 1. That means and then when I put this in a calculator, it will give me minus 2. That means the x value, okay, of this coordinate here is minus 2. I need to solve the y value, which represents this whole expression. That's the minimum value that we are really looking for. So that means I must substitute minus 2 back into the equation. We've solved what x should be so that we get a minimum value. So we're just going to simply, let me put that in an equation. I've got a square root, x squared, that's minus 2 squared plus 2, oh no, it's 4, plus, I'm looking at this one, 4 times x, which is minus 2, plus 13. Okay, now I want to put this whole thing in a calculator, so I'm gonna put square root, and then I'll put it exactly as it is. Negative 2, close it, I'll square it, plus, open another one, negative 2, I'll close it. Oh, there's a 4 that side. There's a 4 here. It's 4, I'm always forgetting it. And then plus 13. I put it exactly as it is. That's equals to 3. So that means, therefore, my minimum value is equals to 3. That's it. Okay, if you didn't understand this, just try to rewatch what I just explained. Other than that, let's go to the next question. Okay, let's do question 2 now. It says simplify the following expressions without using a calculator. Leave your answer with positive exponents and rational denominators. Okay, let's see. Let's start with 2.1. Actually, I want to write it in black. So I've got a square root of x to the power 5 times a cube root of x divided by 6 root x to the power 5. Yeah, that's it. So here I'm going to change everything to fractions just to get rid of the square roots. So I have x is equals to 5. Remember, if there's no number outside the square root, then it's 2. So 5 over 2 times x. Remember, if there's no number on top of the x, then it's an imaginary 1. If there's a number outside, you always divide with it. So it's a 3. Underneath, it's x. The number is 5, so it goes on top. Divided by the number outside is 6, so it divides that exponent. Okay. So eventually, I'm left with x. If you remember the rules of exponents, if you are multiplying the same base, you add the exponents. So I have 5 over 2 plus 1 over 3. And then remember, when you are dividing the bases, you subtract the exponents. Minus 5 over 6. Now, let's just put this in a calculator. Let's see what it gives us, right? So I'm going to have 5 over 2, go to the side, plus 1 over 3, go to the side, minus 5 over 6. It's going to be equals to 2. Right. Now, it said leave with a positive exponent. 2 is a positive exponent. So there we go. Done. Let's go to the next question then, which is 2.2. Now, 2.2 says 7 plus square root of 5 over square root of 5 minus 1. Well, I hope you remember what to do here, and it's called rationalizing the denominator. That's why it's speaking of rational denominators. You rationalize the denominator because it has a surd. So what you do is that you multiply to get rid of this. You go to take the surd, which is square root of 5, and then instead of multiplying with a negative, you put a plus. Why do we do that? So that they can subtract each other. Then you put that number there. Now what you do at the bottom, you must do on the top as well. So I'm going to have square root of 5 plus 1. Okay, so now it's like I'm multiplying that with that. Cool. So we are gonna go, let's start on top. 7 times square root of 5 is just 7, the square root of 5. 7 times 1 is just 7. And then we'll do this one as well. square root of 5 times square root of 5 is plus 5. Remember, when you multiply the square roots, they cancel each other, then you get the number inside. And then square root of 5 times 1, which is get plus square root of 5. Now let's go to the bottom. Let's do the same. Square root of 5 times square root of 5, you get 5. And then square root of 5 times 1 is just plus square root of 5. Now negative 1 times the square root of 5 is negative square root of 5. This is exactly why we do the rationalizing, so that the square roots, they subtract each other. Then the last one is negative 1 times positive 1, which is negative 1. Finally, we just combine all the numbers. Then I'm going to have square root. This one I'll combine it with that one. So it's square root 7 square root of 5 plus square root of 5. That will give me 8 square root of 5. And then 7 plus 5, that's plus 12. This is divided by, we start with this number, 5 minus 1, that gives me 4. Well, these ones, they cancel each other. Plus square root of 5 minus square root of 5 is just 0. So finally, I can simplify this further because I see all of these are common factors, but let me just separate them. Okay, over 4 plus 12 over 4. This will then give me 4 goes into 8 twice, so it's 2 square root of 5 plus 12 divided by 4 is 3. This is rationalizing the denominator. Oh, that was a lot. Let's go to question 3. Okay, let's look at question 3 now. It says if 2 cos theta plus 1 is equals to 0 and sine theta is less than 0, determine without the use of a calculator and with the aid of a diagram the value of that. So let's start with the diagram. In order for us to draw the diagram, we need to determine which quadrants we're working with. So right here, let me put this in a standard form first. 2 cos theta plus 1 is equals to 0. So what I'm going to do is take this 1 to the other side. It becomes 2 cos theta is equals to minus 1. And then cos theta is equal to minus 1 over 2, which is divided both sides by 2. So I can see that I'm looking for a quadrant where cos theta is negative, because there it is, and also sine theta. This means sine theta is negative as well. Okay, because this condition says it's negative. So if I draw my cast diagram, then I say, where is cos theta negative? It's negative in this quadrant, and it's also negative in that quadrant. Where is sine theta negative? Sine theta is negative in this quadrant and in that quadrant. So I've got 2 ticks here, which means my diagram is going to be exactly there. So this is going to be my diagram right here. I'm gonna have it like this right there. So my theta is there, and I've got numbers I can substitute. The only numbers are with the cos. So remember, cos using SOHCAHTOA is adjacent over hypotenuse. So where there's an adjacent, it's -1. Adjacent is right here, it's -1. Hypotenuse is always positive 2. Now I need to complete this triangle by solving this other side. We're always going to use Pythagoras. We're looking for the opposite side. It's always going to be the square root of the big side, which is 2 squared, minus the smaller side, okay, which is 1 squared. So what's 2 minus 1? Right. That's the mistake we make often in the test, don't we? It's 2 squared, which is 4, minus 1. And that's square root of 3. So it's the square root of 3 over here. Now, when we can now answer the question using this diagram. The first one, which is 3.1, is tan theta minus sine theta. Okay, using the diagram, what's the value of tan? We know based on SOHCAHTOA, tan is the opposite, which is square root of 3 over the adjacent, which is -1, and minus sine is the opposite, which is square root of 3 over the hypotenuse, which is 2. Let's just put this in a calculator. Don't even try to do it in your head. Square root of 3 minus the square root of 3 over 2. That's not how I want it. Start again. So square root of 3. Let me actually put it with that -1 exactly as it is. So square root of 3, go downstairs, put that -1, and then you can go to the side, and then you'll say minus, put the fraction again, square root of 3, go downstairs, put it 2. So that's our answer. Minus 3 square root of 3 over 2. Cool. Let's see the next one. The next one is 3.2. This time we are given 2 sine squared theta minus cos squared theta. This we can rewrite it like this: 2 open bracket sine theta squared minus open bracket cos theta squared. Now we can say 2, let's go see what sine theta is. Its opposite, which is square root of 3, square root of 3 over hypotenuse, which is 2, and then squared, minus this side, the cos is -1 over hypotenuse 2 squared. Now we just have to do some gymnastics. Well, you could put this in a calculator if you want. I assure you the calculator can handle this. So it's 2 open brackets a fraction square root of 3, come downstairs, put it 2, go to the side, close that bracket and square it, and then go minus, open the bracket, put the fraction, put the -1 over, put it exactly as it is, 2, go to the side, close that bracket and square it. What do we get? We get 5 over 4. That's our final answer. That's it. We're done with question 2. No, This was question 3. We're done with question 3. Let's go to question 4 now. Okay, so question 4 says prove that the left hand side is equals to the right hand side, basically. So with these kind of questions, what we want to do is to take one of the sides. Let's take the left hand side, and we have to kind of, you know, simplify it. 1 minus sine theta plus 1 over 1 plus sine theta. Now this should be equals to the right hand side, which is 2 over cos square theta. Now let's not try to force things. Let's just do things step by step to see what happens. Now if you have a fraction like this, we are basically adding a fraction, even though it has sine thetas, but it's just basic fraction addition. So what do we do when we have such a scenario? What we do is we start with the denominator, and then we multiply the denominators that we're given, sine, and then that 1 plus sine theta, and then with the numerators we cross multiply. So this one, we go over and multiply that one, and this one will go over and multiply that one. So I have 1 plus sine theta. There's no need to multiply anything. Multiplied with 1 is itself. Then this plus, this side I have 1 minus sine theta. Okay, so let's see what happens when we combine these. That 1 plus 1 gives me a 2. That plus sine theta minus sine theta, that's a 0, so I don't have to write that. But the bottom, we have to multiply it out. 1 times 1 will give me 1. 1 times sine theta will give me plus sine theta. Right? And then I have minus sine theta times 1, which will give me minus sine theta, and then minus sine theta, okay, times sine theta. That will give me minus sine squared theta. Okay, so this is now going to be 2 over 1. These two cancel each other. Sine theta minus sine theta, that's equals to 0. And then this one is just minus sine squared theta. Now, there's something I want to show you on the side here. On the side, we must know that sine, this is an identity, squared x plus cos squared x is equals to 1. Always. So that means that if I take the sine squared theta to the other side, and then I'm left with cos squared x, this is equals to 1, and then I take the sine squared x to the other side, it becomes 1 minus sine squared x. This is a square identity, and this is identical to what my numerator and my denominator is. So which means I can rewrite this as 2 over cos squared theta. Therefore, I can now conclude the left hand side is equals to the right hand side, which has proved it. This is equals to the right hand side, which is what we were given. Well, that's it from me. I hope you understood. Please study more of these questions to really ace your test. Okay, well, that's it. Goodbye.